1 mole of gas has volume V equal to 1.23 times 10 to the power of negative 2 meter cube and pressure P equal to 2 atm. Find the average translational kinetic energy for the molecule of the gas. The average translational kinetic energy of a molecule for gas can be obtained according to kinetic theory of gases from these equations, which is 3/2 kT. But the T, which is the temperature in Kelvin, is not given in the equations. So that means we cannot directly use this formula by substituting the value of the T. What we can do is that we find the relationship between the T and the value of the P and the V given by the equations. To get the relationship between the temperature T and the pressure P and V, we can use the equations of the equation of state, which is the ideal gas law, where the PV equal to NKT. Capital N is the number of molecule, K is a Boltzmann constant. So from these equations, we have the KT equal to PV over N. And we name these equations as the equations number 2. Now we can substitute the equations number 2 into the equation number 1 to obtain the expressions for average translational kinetic energy of the molecules of a gas equal to 3/2 PV over N, where the N now, take note that this N is the total numbers of molecule, and for 1 mole of the gas, then of course this N will be equal to the Avogadro's number. Now we can substitute value where the P is a 2 atm in Pascal. It is 2 times 1.013 times 10 to the power 5 Pascal. And V in meter cube is 1.23 times 10 to the power of negative 2. And this N, as mentioned just now, it is equal to the number of Avogadro because of the gas that we consider is the number of mole is 1 for the gas that we consider. Therefore, now we obtain the average translational kinetic energy for the molecule of the gas is equal to 6.23 times 10 to the power of negative 21 joule.